All right, good morning, boys and girls. It's Tuesday, and we are on lesson 8.6. Yesterday, you took the mid-chapter checkpoint. The ones that I've graded have come out so well so far. I'm very proud of you. I do need everyone to pass those in. Those are due today. So make sure I need to physically see the quiz somehow. Whether that's taking a picture and sending it to me or uploading it on Google Classroom. And if you have any questions on how to do that, please reach out. All right, today our lesson is about relating fractions and whole numbers. The word relate, what you're going to be doing is a lot of comparing, and that's why I wanted to show you that video on equivalent fractions last week, because I think that's going to make this lesson easier. Just a little bit of a warning, there's a few questions here that are a little confusing, but we're doing this question by question together. Before I began, I wrote a note for myself that says, remember that when the numerator and denominator are the same, it is also one whole. That is going to appear a lot in this lesson, so keep that in mind. We learned that last week. Here we go. First, last name, and the date. And it's Tuesday, and I believe it's April 1st. Is it? This is getting scary, everybody, that I don't know what the day is anymore. It's Tuesday. I'll leave it at that. I need a sip of this. My good old coffee. It's the one thing I cannot run out of. You all know. That would not be good. All right, here we go. Unlock the problem. Steve ran 1 mile and Jenna ran 4/4 of a mile. Did Steve and Jenna run the same distance? Well, some of us already are remembering this rule here, that when the numerator and denominator are the same, it's also one whole. So I'm leaning towards saying yes, but let's look at this number line to really see it. So fill in just like we did the other day. They're all going to be out of 4, right, because that's our total number. All 4 parts is your denominator, 3/4 and 4/4, and we know that that's also one whole. Okay, so the distance 1 and 4/4 at the end, are they the same? Are they equal? What do you think? 4/4 lines up perfectly with 1. So Steve and Jenna ran the same distance. All right, these unlock the problems, I have to say, are usually the hardest of the lesson because they're so step by step that sometimes it gets a little confusing. Here we go. Complete the number line, locate and draw 3/6, 6/6, and 1. Tongue twister. Now remember, these two, I'm going to ask you through the screen, are they the same? You should say yes. These are equal. When the numerator and denominator are the same, it's also one whole. But let's fill it in. Let's go right down. Okay, and then 6/6, one whole. You always want to do that extra amount so that later on it's easier. All right, are 3/6 and 1 equal? Explain. Well, here's 3/6, right? Oh, it says locate and draw points, so here's this one. 3/6 is not the same as 1. They're not in the same spot, so do the distances end at the same point? No, they don't. And it doesn't ask to explain other than no, they don't, because they don't end at the same point, right? That's literally your explanation. Okay, so 3, 6, and 1 are, and we're going to use unequal. Okay, prefix. All right, are 6, 6, and 1 equal? Explain. And it's telling us, think, do the distances end at the same point? And we've learned previously that yes, they are equal. When the numerator and denominator are the same, it's also 1. So yes, they are equal. Because the points end in the same spot, you could say. A few different ways you could word that. So 6, 6, and 1 are equal. All right, everyone. I hope we're feeling good. Take a deep breath. Here we go. Connect. The number of equal parts the whole is divided into is the denominator of a fraction. The number of parts being counted is the numerator. New vocabulary here. A fraction greater than 1 has a numerator greater than its denominator. So prior or before this lesson, we've always been learning about fractions where the numerator is smaller, right? It's always been that top number is bigger than the bottom. Now we're going to introduce something new where the numerator is bigger than the bottom number. And I want you to think, in previous lessons, we've been trying to figure out how many equal parts something is divided into. Now we're switching gears and we're trying to figure out, we're going to have the equal parts. We're going to be given that. And now we need to know how many wholes there are, or how many, right? Like 1 whole, 2 whole. That's what we're kind of figuring out. All right? Really switching gears here. Still using the same knowledge though. So each shape is 1 whole. You can see that. Yes, it's dividing into pieces, but the shape itself is a whole, right? Write a whole number and a fraction greater than 1 for the parts that are shaded. Here we go. There are 2 wholes. 1, 2. Each whole is divided into 4 equal parts. 1, 2, 3, 4. Good. 2 wholes. There are blank equal parts shaded. Okay, we have 2 wholes that are divided into 4 equal parts. So think back to the beginning of the year. 2 times 4 parts, you're going to have 8 equal parts total. And this is why division is similar to fractions. So here's your total equal parts among both of those wholes. Both of those circles have 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts total among the 2. And then this is how many each piece has. Okay? Let's do another one. There are 3 wholes. 1, 2, 3. However, each whole is divided into 1 equal part, right? It's just 1 part. This whole is just 1 part. There's not separated down the middle, nothing. Just 1 part to each whole. So, all together, you have 3 equal parts. All right? We know that 3 divided by 1 is 3. Okay. Explain what each whole is divided into 1 equal part means. So what that's saying is just that the way to word that is saying that the denominator of the fraction is going to be 1. Because that's how many parts. Our denominators are usually the total parts, right? We've been learning that this whole chapter. Is 1 equal part. Okay, and I might give an example. Here's the fraction, and I'll circle that one. It's not divided into 2 equal parts, 3 equal parts, it's just 1 equal part, and there's 3 of them. How do you divide a whole into 1 equal part? How could you divide this circle here into 1 equal part? Trick question, everybody. You can't, right? You cannot divide a whole into 1 equal part. Into equal parts. Right? Because it's already done. You cannot divide a whole into 1 equal part. It is already done. Okay, moving on. Each shape is 1 whole. Write a whole number and a fraction greater than 1 for the parts that are shaded. Well, looking at all my past examples, the numerator was always the total number of parts, correct? So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 total parts. Each shape is divided into how many? 2. That's going to get us the number of wholes. And we know 8 divided by 2, everyone, is 4. Now let's check. Are there 4 wholes? 1, 2, 3, 4. Yes, there are. Maybe you want to label. This is your number of wholes right here. Total parts, how many parts in each shape equal how many wholes. Here we go. Each shape is 1 whole. All right, we've got it. There's not like a big chunk missing, right? It's just 1 whole each shape. Write a whole number and a fraction greater than 1 for the parts that are shaded. Step by step, here we go. There are blank holes. 1, 2. So there are 2 holes. Each whole is divided into how many parts? Well, if you counted, 1, 2, 3, 4. Each whole, each circle here, has 8 equal parts. Now total, we have 2 shapes with 8 equal parts in them. 2 holes, 8 equal parts in each hole. 8 times 2, everybody. There is 16 equal parts shaded total. All right, you have 16 total pieces here, divided among 2 shapes, so 8 pieces and 1. 16 in all. All right, now it says use the number line to find whether the 2 numbers are equal, right? Equal or not equal. Remember, don't forget, this is a quick way to figure it out. Ask yourself, is the numerator and denominator the same? If it is, then yes, it's equal to 1. If it's not, no, it's not. So 1/8 and 8/8. Here's 1/8, here's 8/8. Not at the same point, so unequal. 8/8 and 1. Numerator and denominator are the same, so yes, these are equal to 1. 1 and 4/8. What do you think? 4/8 is right here. 1's over here. Are they at the same point? Nope, so they're not equal. Use the number line again. We're finding whether they're equal or not equal. 0/3 and 1. Here's 0/3. Here's 1. Totally opposite sides. Unequal. 1 and 2/3. 2/3 and 1. They're closer, but they're still not on the same spot, so unequal. And 3/3 and 1. What do you think? Equal, right? Numerator and denominator are the same. And they line line up pretty perfectly, so they are equal. Okay, each shape is one whole. Write a fraction for the parts that are shaded. Remember, this number here, the number that you're given, what is that representing? It's representing the number of holes. Right? Here you have 2, and you have 2 holes here. Here you have 3, and you have 3 holes here. Here you have 1, and you have 1 hole here, and here you have 2 holes there. Now remember, that numerator is the total number of pieces among both holes, among both shapes. Go back to your previous work. We saw here 8 was the total number of pieces among both of these. The denominator was how many pieces were divided among just one shape. And then we get how many holes, how many shapes total. So let's try it out. Let's count the total number of pieces. 1, 2, 3, 4, 5, 6. So that's going to go over here. And how many pieces in just one of them? 1, 2, 3. So there we go. That's how you would do it. That's simple. And because division and fractions are similar in certain ways, we can clearly see that is 6 divided by 3, 2? Yeah, exactly. And you can also use your related facts and do 2 times 3 gets you 6, right? 2 holes, 3 in each, gets you 6 pieces total. All right, let's try it again. Let's get the total number of pieces. 1, 2, 3, 4, 5, 6. There's 3 pieces, so 6 times 3, what is that, everybody? 18. So that goes there. Divided by how many pieces in just one of the shapes? 1, 2, 3, 4, 5, 6. So there you go. And 18 divided by 6 is 3. Number of holes. All right, this one's a little tricky. We have 1 hole, 1 total, divided into only 1 piece. And 1 divided by 1, everyone, is 1. And then here we need to get 2 as our whole. So you're going to take 2 divided by each one is 1 total piece. Okay. Last page. Here we go. It says, make connections. Draw a model of the fraction or fraction greater than 1, and then write it as a whole number. So we're solving, but we are also drawing pictures. Just a quick tip. This is where it relates to division. Right away, I know 8 over 4 is 2. And remember, this is how many holes we're going to have. So I know we're going to have 2 circles. And I know that among both, there's 8 pieces, and each shape has 4. So there you go. That top number is total number of pieces. 1, 2, 3, 4, 5, 6, 7, 8. The bottom number is how many pieces in just one of the shapes. 1, 2, 3, 4. And then this is how many holes. 1, 2. All right, so for number 13, I know that 6 divided by 6 is 1. All right, so I'm going to have 1 hole, and it's going to be divided into 6 pieces. Let's try to make this nice and neat. 1, that could be a lot better. 1, 2, 3, 4, 5, 6. Now for this one, I know that 5 divided by 1 is 5. So I'm going to have 5 holes. 3, 4, 5. Okay. Now each piece is divided 1 time. Are we all set? Yeah. It doesn't go any farther than that because each of those 5 are divided 1 time. which is the way it is already. Okay, number 15, we are skipping, but I am going to explain it. If 15 is very challenging, that's okay. It's worded very strangely. Jeff rode his bike around a bike trail that was 1/3 of a mile long. He rode around the trail 9 times. Write a fraction greater than 1 for the distance. How many miles did Jeff ride? Okay, so we know that the total number of times, think of that as like total pieces, is 9. And we learned that 1/3 around that bike trail, which he did 9 times, is 1/3 of a mile long. I'm going to put that 3 there because we want to know how many miles Jeff rode total. And again, relating this to division, 9 divided by 3 is 3. And we're going to label miles. Okay, don't stress about number 15 if you're still confused about that one. All right, what's the error? So something's wrong and we need to explain why. Andrea drew the number line below. She said that 9/8 and 1 are equal. Explain her error. So see this here? Something's wrong. So what is wrong? Andrea is incorrect because how can we word this? Well, first of all, she didn't finish the number line. 9/9 is the end of the number line. Because 9/9 is 1 whole, not 9/8. I'm going to write, she didn't finish the number line. And so then she must have gotten confused. Andrea is incorrect because 9/9 is 1 whole, not 9/8. She didn't finish the number line. Okay. Number 17, each shape is 1 whole. Which numbers name the parts that are shaded? Mark all that apply. When you see mark all that apply, we know that there's going to be more than one answer. Well, right off the bat, I know that this is one of them because there are 4 holes. So that's one way to look at this. Now, I also am looking at the others, and this sticks out to me because I know that 24 divided by 6 is 4. So I really need to know those multiplication facts, everybody. So again, 24 is the total number of pieces among all the shapes. And if we counted all of these, we would get 24. And here, this number, the denominator, 6, is how many pieces are in one of the shapes, which again is 6. So this one shows that model as well. All right, I know that was kind of a lot for a lesson, but just like last week, we had one of those lessons that was harder than the other, and I think that's this one for us. So tomorrow, we're having our 8.7 lesson, which I will upload as well. Now, I'm uploading a lesson for every lesson we do on YouTube. However, not for the mid-chapter checkpoint because that's a quiz. I want to see how you do on your own. So some of you are still working on getting those in, and that's due today. Take a break later tonight, maybe come back and do the homework. All right, and then tomorrow we're going to be learning fractions of a group. All right, everyone, I hope you have a wonderful day, and I'll talk to you later.